Within eShape, we have different pilots. You just saw one. I want to emphasize a bit on the work we did in another pilot, where the starting point is a bit different. So here we looked at how EO data can be used for the agro industry in a bit of a broader context, where we will look at a specific use case for seed producers. The starting point of this whole pilot is actually an existing platform that has been developed to bring EO data to the farmer. So in Belgium, we have the Watch and Grow application, which has been developed specifically for potato growers, and then Jurgen will tell a bit more about the application itself. But so it has different functionalities, and it's really about bringing the data to the farmer. But not just the pretty maps, as was mentioned earlier, but also more actionable information about what he can do to improve his production as well. So there's a whole range of products. I will not go over them completely. It's just about the data, not only EO data, but also other types of information. So it enables and it tries to also play a role in bringing together different information sources. For example, here, also data on, for example, drones or soil scans or soil samples. So all of them are integrated into one platform, also enabling the farmer to not having to go to each or to different platforms to look at different types of data, but really have like a one-stop shop for all different types of information. So there are a number of functionalities. It's like I said, it's not about just the pretty maps of how it's going this year, but it's also about having kind of the history of the field. So if he registers a field, he can also look at its history, how it's been performing the past year, which crops have been growing on that field and so on, because a farmer not always has that information, and it's quite important to already decide, for example, which crop to grow next season. It's important to know the history. So it's not really that advanced EO data, but it's already quite valuable for different aspects of the cultivation process. Let me see here. So what we try to do in eShape is we have this platform. It's been made for farmers. It works really well. We have good feedback. So in eShape, we really try to see, okay, it's been there for farmers, but how can we really make it work for other actors as well? For example, we make yield estimations, or farmers give the actual yields of that year after harvest. They give it into the dashboard. So we have information on the yields as well. So that also is interesting for a number of actors as well. For example, the processing industry is really interested in, during the growing season, which yields can we expect? But also after the harvest on which yields were actually obtained. If you look at the damages, so there's a component on damages in the field as well. In turn, it can be very interesting for the agro insurance sector. A third possible application is, for example, we also have a tab on application maps, where the farmer and the EO data can be translated into action maps, for example, fertilization maps, irrigation maps. And that's not something we do by ourselves. It's something that we can do together with service providers, where they use our EO data to make their advice more spatially explicit or better. And through this platform, they can then offer it to the farmer as well. So it's initially was just a platform for the farmers, but it's actually been growing and drawn attention from a lot of different actors as well. And I want to highlight one that we did in eShape. It's really looking at, okay, so we do it for farmers, but maybe we can also do it for other people. And here we have seed producers as a use case. So we have a company, CAC Seeds. And one of the things they do is they produce sugar beet seeds to have to be sold commercially. And so they have a lot of fields. If you look at the specific use case, they have a lot of fields where they grow sugar beets for seed production, but they have to be very far away from each other to avoid cross-contamination between the different varieties. So that means you have a lot of fields, very scattered, and for them it takes a lot of time to actually visit all these fields. Especially during the end of the growing season, near June, when they do the harvest. They have to go to each field to see how mature the crops are, or how mature the seeds are, to be able to harvest in time. because they don't want to harvest too early, they don't want to harvest too late because it has a large impact on the seed quality. So it's a quite precise operation, but it takes a lot of time. They have to drive around for a lot of hours. And so they were interested in the use of EO data to help them. And so after talking back and forth, we got to the requirements they would need for this product. So they would like to know when to harvest within a 2-day accuracy. And they would like to know it also starting 2 weeks before the estimated time. So if they could have such a service, it would really help in their daily operations. So we set forth and tried to develop a EO-based harvest date prediction model, which is quite challenging and complicated. And there are different aspects to it. One is actually trying the relation between what we see with the satellites and the actual ripeness of the seeds. So we have evaluated different components there. And once we saw, okay, this is something we can use based on historical data, it represents the ripeness of the crop quite well. We can go forth and try to actually go and predict it. So we need to do some predictions in time, 2 weeks in advance. So the starting point here was we have this service called COPSAR, which enables us to provide cloud-free observations. And it's basically an integration of Sentinel-1 and 2. And through that integration, we can even have good observations of the field under cloudy conditions. So that's a neural network. It's machine learning based, where we integrate Sentinel-1 and 2. And so we thought, okay, so we can do this for actual observations. So maybe we can use a similar approach to make predictions, but instead of Sentinel-1, we use meteorological data. So weather information on temperature, precipitation, solar radiation, and so on, to try to predict how the crop will develop in the coming week, 2 weeks. So we go, instead of filling gaps with Sentinel-1, we go to predicting the values in time with using the weather predictions as well. So usually you have a 10-day or a 14-week forecast of your meteo data. So you can use these forecasts to actually convert them to your EO-based forecast as well. So we developed a service based on that, and then you can see the results, how well we did. So how well were we able to actually predict the optimal harvest date on the exact day, or within a 1-day or 2-day window, which was a requirement. So here I also want to pick in a bit on what Conrad said about very technical EO data components, pretty images, how it can be used for the farmer, and they don't want to see these graphs, they don't want to see these images. In the end, what it was for the farmer is, if he went to watch it grow and he looked at the overview of all the fields he registered, in the end, all this complicated processing that you just saw ended up in being just a table, one extra column on harvest day, where he could see the estimated optimal harvest date. So you could see, if you have the Y behind the date, it's an estimation. So there we could see, okay, for the first field, optimally it should be harvested on the 10th of June, the other field on the 19th of June, and the one in between, there's no date yet because it's not planned to be within the next 2 weeks. So this is the actual service that we were able to provide. So very simple for the user. It's just a date and an overview, but actually with a lot of complicated EO work behind it. And that's a bit to what Conrad was referring, I think, like this is what we should provide, something very concrete, something very actionable that they can use. If you then look at how useful was it in the end, the table I just showed you, 85% of the fields were within the requirement of the 2-day accuracy, which is, as a scientist, we always think that's great, but for operational use, it's not good enough to really convert or replace the field visits with EO data. They cannot rely enough, because actually the 15% that we do get wrong has quite a significant impact on their operations. So they cannot just replace one by the other, but it is very useful for planning the field visits, because we still provide quite accurate estimations of the optimal harvest time. So they can, instead of just replacing the field visits with the EO data, they can now start to plan their field visits much more efficiently. They know which fields will not need to be harvested within the next 2 weeks, so they don't have to visit those fields. And then the ones that we estimate to be harvested quite soon, they can then visit those to determine the actual ripeness. So was it a success story? Yes and no. We were not able to fully replace their field visits with EO monitoring, but we were able to make their operations more efficient. And from here on, once you have that buy-in, you have their trust and that they can do something with the data, you can actually go to a gradual transition with having more data over the years. You can improve your monitoring system and you can actually make sure that what the added value of your service increases in time as well. So this is one example of how we try to convert the service that we have for farmers to a service for other players in the agricultural applications. Was a very useful lesson, very useful exercise. And then now I can give the floor to Jurgen. He's our business developer, and he will actually talk more about the whole business model behind What You Grow, because it's an application tool which is free for the farmers. So how can we make a free tool still economically viable? That's something that Jurgen will talk about.
Great. Okay, so a few slides on the case study that we did on What You Grow and how to commercialize an application like What You Grow. So a little bit of history. So we started with the research project on potatoes, and more specifically on developing a service, an EO-based service to predict yield for a number of potato varieties in a research-based approach. At the end of the project, we decided that we would take the results of the project and make them available through a application, through a web-based application. We called the or we named the application What You Grow. It was fully developed by VITO, but supported by Belgapom, and Belgapom is the interest organization of the Belgian potato processing and trade industry, which was quite important to have support of this sector. And soon this support also ended up in a partnership with also the Farmers Union in Belgium, where both the Farmers Union and the processing industry supported the further development of the application through a small investment, financial investment for the further development, but also incentivized farmers to share data through the application, which is very important, as the goal was to deliver data-driven advice to farmers. We also built a larger ecosystem around the application, where we also connected machine builders, agro consultancy companies like soil scanning service companies and so on, around the application, which is or proved to be crucial in the further development of the commercial aspect of the application. So why did we start with potatoes? Well, we live in Belgium, and in Belgium we have, as you probably know, optimal growing conditions for potatoes, and there's really a substantial economical value in the whole industry, where we have a large potato processing industry, a lot of farmers that grow potatoes. So the economical value is really important for Belgium as a whole, and that's why we decided to focus at first instance on potatoes, as it is a cash crop in Belgium. Now, it's not only Belgium, so it's in the region north of France, Belgium, the Netherlands, is the so-called potato belt, and there I think most of the European potato processing companies have a factory. Most of them are located in Belgium and the Netherlands, and the whole growing region is in this area that you can see here. So the economical value is also explicitly shown here by the growing employment. So where from 1994 until last year's, employment in the industry, in the processing industry, nearly doubled, but also production grew substantially. So past few years, the total area of harvested potatoes, of number of hectares grown in Belgium, but also in the Netherlands and in France, Germany is growing, as well as the total production, of course. Then. Also in terms of investment, so it's a substantial, so the whole industry makes yearly substantial investments in their both in their factories as in the peripheral parts of the industry, and you see also that it reflects in the total produced amount of frozen potato products. So nearly 2 million tons of frozen potato products, which makes Belgium the largest frozen potato products exporter in the world, followed closely by the Netherlands. So this is Belgium, the Netherlands, really the heart of the potato processing industry. Now, the goal of What You Grow, like Laurent explained, is to in a sustainable way increase the yields of usable potatoes, and all words are important there. So in a sustainable way, but also the usable potatoes. So in terms of quantity and quality of the potatoes, and we want to deliver data-driven advice through the application by creating a digital twin of any field. So the remote sensing data acts as an objective base layer of data, but we complement that data with a lot of in situ data, and coming from various sources. Can be meteo data, can be data from soil scanners, can be IoT data, so data coming from machines. So we connect with a number of machine builders that can exchange the data that they collect on the machine with What You Grow and vice versa. And we have this part where farmers can also manually input their parcel data, so their field management data, which actions did they execute on the field, on which date, which products did they use, in which quantities, and so on. Of course, with the goal to link that with a remote sensing solution, so to use that data to calibrate or train a remote sensing based solution to provide these insights to farmers again with the goal to increase their yields. Obviously, because there is a growing demand from the food processors for potatoes, and the area where that is available to grow potatoes is limited within the region. So the road to commercialization is paved with data, as you understood. And so we are very data hungry, and there lies also the challenge. Like also the previous speakers explained, with only the remote sensing data, it will not be possible to come up with viable solutions. We need other sorts of data, in situ data as well, and there we need that data to support 3 types of users in the value chain. So specifically here, not specifically only targeted for potatoes, but in the potato use case, we identified as primary users farmers and agro consultancy companies. Secondary users, the processing industry, traders, machinery industry, input suppliers, and so on and so on. And then lastly, the tertiary users can be supermarkets, but obviously also citizens. So we try to cover the whole value chain with solutions, as Laurent already explained in the previous presentation, and not only focus now on potatoes, but are expanding towards other crops as well, but trying to link that with the various stakeholders in the value chain. So when we talk about sugar beet, we also look, for example, to the sugar processing factories and to seed breeding companies in sugar beet, for example, and try to involve them in the application and try to service them with the EO-based solutions that we develop through what you grow. So looking at the primary users there, I think they're really the key stakeholders, but most difficult to convince. And here we have a little bit the chicken and the egg problem. The farmers are only willing to use the application, to feed the application with data and to pay for the application whenever it delivers actionable insights for them. But of course, we first need the data before we can deliver actionable insights. So we're not yet at that point where we have enough data to bring enough added value to farmers. So we need, for now, to look at mainly the secondary users. And there we found that the willingness to pay is a little bit higher. Especially the processing industry and the traders, they see the long-term benefit of a datafication of their activities, and they have also a better view on the future challenges. So the Green Deal has been mentioned here before. I think that these companies really understand that they need data and objective data in order to be able to meet the challenges put forward by the Green Deal. At the same time, they have many other challenges that they face, and with a higher short-term return on investment. They can improve their efficiency in the factories with 1% or even with 0.5%. The return on investment there is immediate and much higher than investing in a long-term solution that is remote sensing based. But nonetheless, we found them willing to invest in the future development of the application, and they provided an indirect contribution by setting up a bonus system where they incentivize farmers to feed the application with data. So whenever a farmer delivers the parcel overview that they need to deliver anyway when they deliver potatoes to the factory, when they deliver that in a digital form through the Watch It Grow application, they get paid a compensation for that to incentivize them to input that data into the application and also deliver that in a digitized way, so that we can use it also to develop new products. We have links now with the machinery industry where we can take in the data that they collect on the machines through an API, but also provide them added value to the forms of an actionable map and that they can feed in their machine. So there is a two-way exchange of data where at this stage no euro transactions are involved. So it's some kind of an in-kind transaction that we have set up there for the machinery industry. With input suppliers, we provide them with ad hoc or project-driven solutions, and the maps that Laurent showed on the yield potential, for example, is something that we is data or insights that we deliver to these type of companies whenever they are scouting for new fields, for example. And then with the insurance industry, exactly the same. We didn't manage yet to set up a long-lasting partnership with these companies, and there it's mostly always ad hoc or again project driven that we work with them. But the willingness to pay for the insights is there a little bit higher than with the farmers. Then the tertiary users, there we're still looking into the valorization through improving traceability. Blockchain has been mentioned here before. We're looking at that technology as well, on how we can link and provide insights farm to fork in this potato use case. But there is an important issue to be solved, and that's in the storage part, where mainly farmers store all their potatoes that they harvest from all their fields in one shed, so they don't split that up. So there the traceability challenges needs to be solved first. And then, of course, in sustainability, I think there is a huge potential. If you check the goals being put forward in the Green Deal, it's very clear that the EO-based services will have a substantial contribution in monitoring the environmental and the biodiversity improvements, but it will also play a role in helping the industry reduce the amount of agrochemicals used on field. So, as everybody understood and mentioned several times before, data here is really key. Without huge amounts of in situ data, it's very hard to deliver real added value products to the farmers for which they want or willing to pay. And we focus on the short term on the secondary stakeholders as both commercialization partners, but also we believe that they will be important for user uptake by setting up these bonus mechanisms. For example, we see that farmers are, or we have a growing user base of farmers that use the application and feed the application with data, which would not happen without this engagement of the industry. In terms of business models, it's an ongoing search on how we can valorize the results better. But I think we still need more added value and thus more in situ data before we can really start to build a economically viable solution out of what you grow. So I think for now and for the next few years, we'll still be in the investment stage, both from a data collection as from a monetary perspective. So that was my part of the presentation.